Hello, welcome to this video today. Today we're going to see a small example for computing a line integral. So the function that we are going to look at is a function defined on R3. And remember, we need real values for the line integral so far. And we'll define that function as f of x1, x2, x3 being x1 squared plus x2 times x3. And we like to evaluate that on the helix. Remember, the helix was defined as a curve on an interval. We just take one rotation of a helix here, so we'll use the function from 0 to 2 pi, and that maps to r to the 3. It's defined as gamma of t. In the first two coordinates, what we do is basically a circular motion, so we have cosine t, sine t, like in the two-dimensional circle. And then in the third coordinate, we just increase the x3 coordinate. So we move up while we rotate. So we have this circular motion. At the same time, we're rotating up. So that gives a helix here. And we like to integrate f along that helix. So what we want to do is we want to evaluate the line integral of f ds over gamma. Now, to do that, we need to first compute gamma prime. Remember the formula for that line integral here? That was the integral of f of gamma of t times the norm of gamma dot of t dt. And the boundaries for the integral were just the boundaries of the interval. So in that case, 0 to 2 pi, so the domain of the curve. So we need to compute gamma dot, and subsequently we need to compute the norm of gamma dot. So in this case, we have the derivative of the cosine, that is the negative sign. We have the derivative of the sine, that's the cosine, and of t, that's just 1. So the derivative is easy. The norm of gamma dot is then almost as easy. That is the square root of minus sine t squared plus cosine t squared plus 1 squared. So what we get here is, remember, sine squared plus cosine squared is 1. So we have 1 plus 1, so that's just the square root of 2. So in this case, that norm of gamma dot is even a constant. And of course, that should make things pretty easy. That means we're all set to compute this integral. And as I said, this is the integral from 0 to 2 pi f of gamma of t times norm of gamma dot of t dt. So what we get is the integral from 0 to 2 pi f of gamma of t. Remember the definition of f here. F is x1 squared plus x2 x3. And gamma is cosine t sine t t. So x1 is cosine t. That means we have cosine squared t plus x2 is sine t and x3 is t. So that x2, x3 expression is just t times sine t. So that's f evaluated at gamma of t. And then we need to multiply with the norm of gamma dot, and we just computed that to be square root of 2. So that's the integral that we have to evaluate. And that is same thing as square root of 2 times the integral from 0 to 2 pi cosine squared t dt plus the integral from 0 to 2 pi t sine t dt. Now let's evaluate those two integrals separately. We first want to integrate cosine squared. To do that, we rewrite that as cosine t times cosine t, and then we apply integration by parts. This will be u, the second factor will be v prime. What we get then is, well, first we need u times v, so that is cosine t times sine t. So we integrate cosine t to get from v prime to v, that's sine t. And then we need to subtract u prime v. U prime, the derivative of the cosine is a negative sign. So with this negative sign right here, negative times negative is positive, so we get a plus sine t times sine t dt. Now what that is that's the same thing as cosine t sine t, we'll just keep that, plus, and here we have the integral of sine squared t dt. Now that integral of sine squared, that is the same thing as the integral over 1 minus cosine squared t dt. And somehow we back at that cosine squared. But that's one of the things that often happens with integration by parts, and sometimes it's helpful. In this case, it actually will be. Just bear with me for a second. So we get cosine t sine t. We integrate that 1, that's just given as a t. And then we have minus the integral of cosine squared t dt. So what can we do now? Well, we have an equation here that says this integral is equal to this expression. And we can now try and solve this equation for the integral that we're actually looking for. So what this is equal to is, that is 2 times the integral of cosine squared t dt. I'm just bringing the integral to the left-hand side, is cosine t sine t plus t. So what we get, just need to divide by 2, is that this integral of cosine squared t dt is equal to 1 over 2 cosine t sine t plus t. And that's how we compute the integral of cosine squared. Okay, so that's the first part. First thing we need to do. Remember, we have one more integral. We have this integral of t sine t. But that is going to turn out to be far easier, fortunately. So, second part we need to compute is the integral over t sine t. And as you probably guessed, that's also integration by parts. So let's just designate t as u and sine t as v prime. And then when they swap roles, so we'll exchange this by u prime v, basically. That means the t will vanish through differentiation. The sine t will turn into a cosine, but it's easy to integrate a cosine, so that doesn't hurt us a lot. Okay, so again, integration by parts. And what we get here is now t times the integral of sine t. The integral of sine t is the negative cosine, so we have minus cosine t here. And then we need to subtract u prime, that's just 1, times v, and again v is the negative cosine, so this becomes a plus here. And of course integrating the cosine is also not that hard, so we have minus t cosine t plus, and the integral of the cosine is just the sine. Okay, so that's how this second integral here is computed. Now remember, we wanted to evaluate this line integral of f along gamma, and this is the expression that we came up with so far. So let me just copy that, and that means the line integral of f ds along gamma. That was the same thing as this expression here. And now we can say this is the same thing as square root of 2. And we have evaluated these two integrals. Integral of cosine squared t is this expression here, 1 over 2 cosine t sine t plus t. 1 over 2 cosine t sine t plus t. And we need to evaluate that at 0 and 2 pi. And then we add the integral of t sine t, which is this expression, minus t cosine t plus sine t. And again, from 0 to 2 pi. So what do we get? This is the square root of 2. Let's see, if we substitute 2 pi in here, then the sine of 2 pi will be 0, so that part just vanishes and we're left with 2 pi. So that's 1 over 2 times 2 pi. And then we need to subtract that expression at the point t equals 0. For t equals 0, the sine is again 0, t is also 0, so we just subtract 0 here. And then we get this second part here. And here what we get is, first at 2 pi, we have minus 2 pi times the cosine of 2 pi. Cosine of 2 pi is the same as the cosine of 0, that is 1. So that gives us minus 2 pi plus the sine of 2 pi, that is 0. Minus, and now we evaluate that expression at 0. Well, this is 0 for t equals 0, and again the sine is 0. So again, we get a minus 0 here. So all in all, what we have is the square root of 2. And 1 over 2 times 2 pi minus 2 pi. So this is pi minus 2 pi. And we are left with minus pi square root of 2. Okay, so this is the result of our integration, and this completes our example of computing a line integral. I'll see you in the next videos.